So with this video, we start block number 4, which will be devoted to two additional topics. It's analysis of qualitative data, as well as using non-parametric tests. So in this block, we will have only two learning sequences. So let's start with analysis of qualitative data. First of all, I must say that both learning sequences are heavily based on the topic that you have already learned in the previous three blocks. So therefore, it is assumed that you already know, for example, the content of block number 2 very well. So let's talk about the qualitative data analysis. You can see the outline of the learning sequence here. So let's recall, first of all, what qualitative data is. This is the slide that I showed in the first learning sequence of this course. The idea is that the variables, the characteristics that you measure, can be represented in many different ways. The two main different ways, it's the quantitative and qualitative representation. So when you represent something with a number, and this number gives a meaning, so it means it provides you an idea about the amount of this particular characteristic, that's what we call a quantitative variable. So a quantitative variable, it's something that can be expressed in the numbers, and this numbers has a direct meaning. Number has a direct meaning. And qualitative variable, in contrast, so it's something that cannot be represented with a number. It's a category or quality, so that's why it's called qualitative variables or categorical variables, okay? And then, for example, you know that when we talk about numeric variables, quantitative variables, they can be discrete and continuous, while when we talk about, for example, qualitative variables, they can be ordinal and non-ordinal, right? So qualitative variable, it's something that can be expressed using a limited set of categories. From that point of view, qualitative variables are somehow similar to discrete numeric variables, because in discrete variables, we also have limited amount of these values, right? But in this case, these values are not numeric. However, you may have categorical variables that can be ordered. So it means that you can kind of add a rank of these categories and then order these categories by rank. But in this learning sequence, we will not distinguish between these two. We will treat them as just purely categorical variables without using this idea of ordinal or not ordinal variables. Now, let me show you one of the data set that I'm going to use in this learning sequence, and you can also download it if you take this course officially from the university. You can also download this data set from the course materials. So this dataset is actually a real dataset. I made a survey in one of my lectures where I had approximately 141 students. I made a survey and I asked 4 questions. Which soda drink you prefer? They were given 2 choices, either cola or Coke, the Coca-Cola or Pepsi. So it means that even if they don't drink soda, for example, if they don't drink neither of these 2, they had to select one of these 2. And then the similar questions for fast food restaurant. So they were given 3 choices: McDonald's, it's MD for short here; Sunset Boulevard, it's SB for short here; and then finally Burger King, it's BK. Okay. Again, even if they don't like these restaurants or they don't use these restaurants, they had to select one of these as a preferable. Similar about Cinematic Universe, Marvel and DC. And similar about smartphone. Is it Android-based smartphone or iOS smartphone they have, actually? Okay. So this is the data set. So it consists of, it says 142. I think it's 141. We will see it also later. I made a mistake here. 141 records. So we have 141 students who answered these questions. So that's my sample size. So you can think about this as a sample taken from a big population, which you can think of all students, for example, of our department, okay? And then the problem, you can see immediately the problem, right? It doesn't look like a table or data we used to in the previous 3 blocks, right? In the previous 3 blocks, we could see some numbers here, numbers. In this case, we don't have numbers at all. It means that we cannot use the statistics, the plots, the statistical tests that we used to in the previous learning sequences, right? So we cannot use, for example, we cannot compute average or standard deviation or similar statistics. So that's why you have this learning sequence. I'll show you how to summarize, how to describe this kind of data, how to make also inference and all that kind of thing. So you still can do it even if the variables are categorical, so they are not numeric. So this is what this learning sequence is about. This is the file name of the data set. So if you take this course officially, you can just download it and follow all examples as well. If we talk about description of the qualitative data. So now we have a sample, and we would like to describe the sample using different statistics, right? We have actually 3 main statistics that you can compute, and you already know them all. It's just another way to look at these statistics. It's frequencies, proportions, and mode. I'll combine manual calculations and R code in this case, so you will learn both how to do all this, how to calculate these statistics manually and by using R. And then in order to run the R code, first of all, you need to read the data set. So this is why you have this code here, read Excel, and then you remember that you need to load library read Excel if you want to read this Excel file, okay? So the first statistic is frequency, and that's what you learn from the histograms, right? So you remember in histograms, we count how many values lie within a given interval of the values. Here we don't have intervals, we have categories, so we simply count how many observations have this particular category. For example, if we talk about Pepsi and Coke, we can count how many people selected Pepsi, how many people selected Coke, and that will give us a frequency. So you can see, for example, that in R, to calculate frequencies easily, you can use a function that is called table. So table simply takes all categories that you have in a particular variable, and then count how many entries every category has. And then you can see that I applied this to a column fast food. It provides me the frequency table, right? So this is how many students selected Burger King, how many students selected McDonald's, and how many students selected Sunset Boulevard. So these are counts, these are frequencies. So this is number of students. So the second statistics, proportions, you know this as a relative frequency. So relative frequency is when you compute a percentage of every frequency, right? So in this case, what you need to do, you need to take every frequency, every individual frequency, and then divide it to the total number of entries, right? So in this case, I can compute total number of entries by just summing up these 3 values, and then I take every value and divide to the total number of values. In this case, it's 141, and then you can see the proportions, right? So for example, this one, it's 0.113, it means 11.3% of students selected Burger King, and then this one is 0.543, so it's almost a half, a little bit more than a half of students selected McDonald's, and then you can see 38.3% of students selected, in my sample, selected Sunset Boulevard, and that's what we call proportion. So proportion always expressed between as a number between 0 and 1, but the meaning is it's a percentage. Okay. Finally, mode. Mode is a category that has the highest frequency or highest proportion. So therefore, in this case, we just need to find out which value is the biggest in the frequency table. And that's what you can do with the function which max. If you just run max, it will give you the highest value. But if you run which max, it will give you a position or name of the biggest value in your sequence, in your vector. And that's exactly what we have as 2 here, or MD, McDonald's. And then you can see that indeed, McDonald's is a mode. It's a value with the highest, it's a category with the highest frequency. Okay. So these are 3 statistics that you can use to describe any single qualitative variable. So in this case, we are talking about univariate case. We take one variable at a time, right? You can visualize the statistics using different plots, and the simplest plot will be the bar plot. For example, I just repeat the code that I had before, how to compute the frequencies and how to compute the proportions. So if you run bar plot and then provide the frequency vector with frequencies, and you remember it's a named vector, it also has names of categories, then you will get the plot like this. So you can see this is the category names, it automatically got them from the vector names, and then you can see that this is the frequencies, and then you can see, okay, so this is 18, I don't remember exactly, 16 I think, this is 16, this is, you can see 70 something, and this is 50 something, okay. Of course, you can make such a plot also for the proportions. So in this case, you simply provide the proportion vector. Because proportion vector also has names, so it automatically names will be defined here. And then you can see that the difference is that now it's a proportions, it's not the frequencies. And of course, you can also make a pie chart when it comes to proportions. I think it's also one of the very popular charts, although I don't recommend to use it, especially when you have more than 3 categories, because otherwise it will be very difficult to compare how big the frequencies are. But anyway, you can do it, and this is the example. You simply write pi, and it doesn't matter what you provide as argument, frequency or proportions, it will be the same result, because it's always make the pie chart using the proportions, of course. Okay. And then you can see also it automatically gets the categories names. And then, of course, you can make this much, much more complicated or more nicely looking, so to speak, because as anything in R is just Lego, you can assemble anything. For example, I show you a couple of examples. Here I have a code where I make a bar plot using the proportions. And then you can see I change the Y limit, so it's between 0 and 1, right? Then, of course, the Y lap is proportion, is this one. And then you can see I defined 3 different colors. I know I have 3 categories, so I define a special color for each of the categories. And then I also don't show the borders. So you can see there is nothing here. The borders are, I mean, usually it's a black borders, but it shows nothing as a borders. Okay. And then what else? I also save position of the center of these bars. And then I use these positions to show the text labels. You can see the text labels here, right? So what I do, I simply say, place the text labels. This is X coordinate. It's coordinates of the center of the bars. This is Y coordinates. It's the height of the bars. And then you can see I take the proportions and round down to 2 decimals. So that's why you have 2 decimals here. Here you have 1 because I believe the second decimal is 0. And then you can see this is the size of these labels. This is the color of these labels, and position 3 means on top of these bars, right? And then I also add a box. By default, it doesn't show these lines, the box on the bar plot, okay? And of course, you can make much more complicated. I'll show you also later, much more complicated bar plots. So my point is that you can make whatever you want, okay? Similar to pie chart, you can also change a lot of things in pie chart. You can see that, for example, first of all, I compute the percentage of the, instead of proportions, I compute percentage. How? I take proportion, then I round it to 3 decimals, so it will be like this, and like this, right? But rounded. And then I multiply to 100. So I will get the percentages with 1 decimal. And then I create a vector of labels. So I use these calculated percentages here. And then you can see I add brackets, I add parentheses, I add symbol of percent. And then I also use the names of the categories, right? So it will make a label like this. You can see this is the name, right? This is this percentage that I calculated. And then you can see I added also this on the left and this on the right. This is it, and this is it. So I created vector of 3 labels. You can see the 3 labels here. And then I simply say, okay, make a pie chart using, in this case, proportions. It doesn't matter, as I said, you can also use frequencies in this case. This is the colors, 3 colors for every category. This is the labels, the one I generated, and also show the white borders. You can see the border is white. And then that provides this nice pie chart. And again, you can change it almost whatever you want. Okay. So this is it about how to describe qualitative variables and how to visualize this description, these statistics that you calculated. In the next video, we will talk about how to make an inference.